So welcome you all to our second class of polynomial. So in last class we have discussed the basics of polynomial and geometrical meaning of zeros of polynomial. So today specifically we will discuss on quadratic equation. Okay. So their polynomial we have discussed. According to the degree we can separate the polynomial into many types. So if the degree means highest power, if the degree is 2 means if the highest power is 2, then we can say it is a quadratic polynomial. And if we will make it equalize to something, suppose 3x square plus 2x plus 9, it is the quadratic polynomial. But if I will take that 9 to the opposite side and I will make it equated to 0, then we say it is quadratic equation. Okay, the difference between quadratic polynomial and quadratic equation is equating it with 0. If only the polynomial is given, it is quadratic polynomial. If it is written that equals to 0, it is quadratic equation. Okay, then we'll come to its general form of quadratic equation or quadratic polynomial. It is in the form of ax square plus bx plus c. Okay, so as you know, here highest power is 2. So x is the variable here and a, b, c are the coefficients. So a, b, c are the coefficients of respectively x square, x and the constant itself. So whatever is multiplied with x square is a, whatever is there along with the symbol is multiplied with x, that's b, and the number itself is c. Okay, and coefficients may be real number, it may be any number, 11 by 12, 13 by 18, root 2, it may be any number. Then solution of quadratic equation, and we can also call it zeros of the polynomial. We can solve this, or we can find the zeros using the trial and error method, means putting 1, putting 2, 3, trial and error, or by making a graph. The most commonly and simple method is factorization method. So in factorization method, we will convert the polynomial into its factorized form. For example, if anything is the form of a plus b whole square, if anything is in the form of a square plus 2b plus b square, we can write a plus b whole square. Or if anything in the form of a square minus b square, we can write a plus b whole into a minus b, like this. And the predominantly used one is the middle term factorization. Anything in the form of x square plus a plus bx plus ab, we can write it as x plus a whole into x plus b using the third identity. So in factorized form, we will use the identity. Okay, so it may be any one, maybe first, second, or the third identity, or basically most of time we use the last identity, that is x plus a whole into x plus b equals to x square plus a plus b whole into x plus ab. So this will be in the right side form, expanded form. We will convert it to the factorized form, means x plus a whole into x plus b, then we will make it equate to 0. So already we have discussed x minus 2 is a linear polynomial. What is the value of x? So we equate the polynomial to be 0. So x minus 2 equals to 0. So x equals to 2. So similarly in this case, x plus a whole into x plus b will equate it to 0. So as the product of two things is 0, either the first one x plus a is 0 or the second one x plus b is 0. So similarly we are getting the values of x. So here we can take one example. So x square minus x minus 6. So if we will use the middle term factorization or the last identity, it will be in the form of x plus 3 whole into x minus 2. Then we will equate it to 0. So here x plus 3 is 0 or x minus 2 is 0. So x equals to minus 3 or x equals to 2. So you are getting two zeros. But in previous case, if something is in the form of x square plus 6x plus 9, so it will be x plus 3 whole square. So x plus 3 whole square is 0, that means x plus 3 is 0. So x equals to minus 3. So already we have discussed in quadratic polynomial, the number of zeros may be 1, may be 2, or may be 0, no solution. Okay, so it has maximum 2 solutions. So we will do one example. So write 3x square minus 10 minus 2x in the general form of polynomial. So you may pause the video or try. So it is 3x square minus 10 minus 2x. So the polynomial is always written in the decreased order of exponent. So it is 3x square minus 2x minus 10. And again ax square, bx, c all are positive. So we will write 3x square plus minus 2x plus minus 10. So it is in the form of, now you can check x square plus bx plus c. So a is 3, B is minus 2, C is minus 10. But looking directly, you may think B is 2. So, as it is 2x, but you have to check that it is minus 2x. So, here B is minus 2. Then we will discuss the most important part, that is relation between zeros and coefficients. So, as already I said earlier in this video that a quadratic polynomial has a maximum 2 zeros. Okay. So, for example, that we have solved x is sometime coming 3, sometime coming minus 2. For example, you will take another example. Okay, you will take another example. So, the value of x in your polynomial may be 3 minus 4. Some of your friend will try another polynomial, his solution may be 8 minus 2. So, if we will assume that zeros, okay, so it is not always fixed, sometimes it is 3, sometimes 2, sometimes minus 10. So, in general we take let it be a variable, so let it be x, but the problem is the polynomial is in the form of x. The polynomial is 3x square plus 2x plus 8. So, I can't say that the 0 or the solution, the value of x bx, no, I can say your age bx, I can say let us assume your age is your age, no, it is not possible. Okay. So, as the zeros are different for every case, we want to make it some general term, we want to give it some general term. So, just like when we are solving some questions, we are writing let this be x. So, as here x, y, z are taking as the variable, so we can take the value of x, y, z. And the next thing, a, b, c also we can take. Why? Here a, b, c are also termed as the coefficients. So, a is the coefficient of x square, b is coefficient of x, c is the coefficient of the number itself. So, here we are taking two variables, something different out of this alphabet to make it clear, not to confuse. So, let the value of the zeros be alpha and beta. So, just like we are taking here x and y, so we are taking the value of x, means the zeros of the polynomial, the solution value of x for which the equation will be satisfied, let that value be alpha and beta. Why 2? No, it has maximum 2 zeros. So, maximum cases there are 2 solutions. So, we are taking 2 solutions as alpha and beta. This is for understanding purpose, we are taking alpha beta. Okay. Then if we will closely observe the relation between coefficients and that zeros, we have already solved in middle term factorization, we are factorizing the middle term, means the middle term means the coefficient of x. So, it is clear that the coefficient of x or b has some relation with zeros of polynomial. And also you remember in middle term factorization, we are multiplying the coefficient of a and c, that means the coefficient of x square and the number itself, okay, to think about the possible value of x or the possible solution. That means definitely there is a relation between zeros of polynomial and the coefficients. Okay. And what is that relation? It is sum of the zeros, we have considered the zeros to be alpha and beta. The sum of zeros means alpha plus beta equals to negative of the ratio of coefficient of x square and coefficient of x, means it is minus of b by a. So, you have to simply think it alpha plus beta, sum of the zeros equals to minus b by a, and similarly the product of the zeros, that is alpha beta, equals to c by a. So, c is the coefficient, the number itself, by a means the coefficient of x square. If you think, sir, how alpha plus beta equals to minus b by, how you can say like that, from where the formula is derived? Just you imagine, when we are checking the relation between 3 sides of a triangle. Okay, so what we are doing there, we are drawing one triangle, checking the 2 sides, and we are checking it relation of the other side, it was greater. Similarly, we have checked 5 to 10 times, I am saying it in class 7 concept, sum of 2 sides greater than third side. So, we take several example and we checked triangle 1 case, sum of 2 sides greater than third side. In case of triangle 2, sum of 2 sides greater than third side. In case of triangle 3, sum of 2 sides greater than third side. So, that means we have developed a thinking that if 8 triangles 2 sides is greater than third side, that means all the triangles sum of 2 sides is greater than the third side. Another example I will think, suppose I will ask, how many hands you have? You will say, sir, I have 2 hands. How many hands your father has? Sir, he has also 2 hands. How many hands your brother has? Yes, he has also 2 hands. How many hands your teacher has? Yes, he has also 2 hands. How many hands the shopkeeper has? Yes, sir, he has also 2 hands. So from here, some specific examples, you, father, mother, shopkeeper, teacher, priest. So from the specific examples, we are getting one general idea that every man has 2 hands. Clear? Then I will say, how many hands I may have? Then you will say, sir, you may have 2 hands. Why? Now every man has 2 hands. You are also a man, so you may have 2 hands. Okay, so this type of thinking is called inductive deductive thinking. So first, from some specific examples, we will find the relation. Then we will make it realize for everything. Then we will again go to specific. If it is asking some specific ones, I will say, as man has 2 hands, so you have also 2 hands. Similarly, some mathematicians, some intellectuals observed that whenever we are adding the zeros, the value is coming like this. So from several examples, it was verified. Then it was thought to be a formula. And next, if it is asking someone, array, what is the sum of the zeros in this polynomial? As every polynomial it is satisfied, also for this particular polynomial this condition will be satisfied. Sum of zeros will be negative of b by a. Now I think the relation is clear between the zeros and the coefficients. Sum is minus b by a, product is c by a. Now we will see one example related to this concept. Find zeros of x square plus 7x plus 10 and verify zeros of the zeros with the coefficients. Okay. So first we will factorize this. It is x plus 5 whole into x plus 2 using middle term factorization or third identity, anything you can make. Then to get the value of x or to get zeros of polynomial, we will equate the polynomial to be 0. So you can write either x square plus 7x plus 10 equals to 0, then you can factorize, or after factorizing you can write x plus 5 whole into x plus 2 equals to 0. So in the due process we will get the value of x as minus 5 and minus 2. So then we will check the relation with the coefficient. So alpha plus beta, minus 5 plus minus 2. So it is minus 5 minus 2 minus 7, and alpha beta is minus 5 into minus 2, it is plus 10. Then we will check what is the relation with the coefficients. So we know alpha plus beta is minus b by a. So we check what is b. So here value of b is 7. So minus b by a, that means minus 7 by 1. So that is minus 7. So check what is the sum. Alpha plus beta is minus 7 or not? Yes, verified. The next one, alpha beta, we have got 10. Now we will check its relation with coefficients. So it is ca, we know. So you can check, you can multiply c into a, and you can observe that it is clearly matching. That means it is verified. Now we will discuss its reverse. Just like the rational number is in fractional form, we are converting to decimal form, and again we are reconverting, or we are converting the decimal to fraction. Similarly, here polynomial was given, we are calculating the zeros, and to its contrary, to its opposite, now the zeros are given. Okay, zeros, the value of alpha and beta are given. We have to find out, we have to create the polynomial. Okay, and how we will do it? We will do it using the concept of zeros, relation of zeros with the coefficients. So for example, there we will solve one question. Find a quadratic polynomial if the sum of zeros are minus 3 and product of zeros is minus 2. That means here alpha plus beta is minus 3 and alpha beta means product is 2. So check alpha plus beta is minus 3. Then we will discuss what is the relation with coefficient. Means alpha plus beta equals to minus b by a. So now minus b by a equals to minus 3. By cross multiplying, here I can find out the value of b. So check, minus b by a equals to minus 3, by cross multiplication minus b equals to minus 3a. So what is b? B equals to 3a. Similarly, if I look, alpha beta is 2 given, and alpha beta is also c by a, and equating this c by a equals to 2. So what is c? C equals to 2a. So please look it carefully. B is 3a, c is 2a. You will say a is a. If I am converting b to the form of a, c to the form of a, so a value to be in the itself a. So now I have three values, a is a, b is 3a, c is 2a, means I know the value of a, b, c, but in the term of a. Okay. Then how to find the polynomial? So first I will write the general form of polynomial. So it is a x square plus bx plus c, as already we have discussed. Then we will here put the value of a, b, c. So what is a? A is a itself. So a x square plus b. What is b? B is minus 3a. Then minus 3x plus c. What is c? C is 3a. Means putting the values of a, b and c in the general form. So what I am getting? I am getting ax square plus 3ax plus 2a. So this is a polynomial, but here a is common. So I can take here a common. So after taking a common, I am getting x square plus 3x plus 2, and this is the polynomial having the product of the zeros is 2 and sum of the zeros is minus 3. So it is clear, if alpha plus beta given and alpha beta given, you will equalize it with minus b by a, and from there you will get the value of b and value of c in terms of a. After getting value of b and c and also a equals to a, we will put all these three values in the general form of polynomial. Then we will take common a, and whatever is remaining, that is the polynomial, required polynomial. So as always, there is a shortcut formula for it. If alpha plus beta given, if alpha beta given, we can find the polynomial with a very shortcut formula. That is nothing, the general form of polynomial. If alpha plus beta and alpha beta given, it is written in the screen, check it, x square minus alpha plus beta x plus alpha beta, that is the polynomial. Means x square you have to write nothing, the coefficient of x will be minus of alpha plus beta, and the coefficient of the number itself means c will be alpha beta. So c will be alpha beta product, and b will be minus of alpha plus beta, negative of sum of the zeros. Okay. So it is x square minus alpha plus beta x plus alpha beta. So if it is a 1 mark question, you can directly put the formula to get answer, and we will solve one example in this method. So in just the previous question, if the values are given, alpha plus beta is minus 3, alpha beta is 2. So find the general form. It is x square minus alpha plus beta x plus alpha beta. So x square minus, what is alpha plus beta? It is minus 3. So x square minus 3x plus, what is alpha beta? It is 2. So minus 3 will be plus, it is x square plus 3x plus. So now we will move towards exercise 2.2. Find the zeros of the following quadratic polynomial and verify the relation between the zeros and coefficient. So as already said, you have to find out the zeros. How? By factorizing. You will equalize the given polynomial to be 0, then you will prime factorize the given polynomial, then it is converted as the product of something. So either the first thing is 0 or the second thing is 0. Okay. So whenever one is 0, you equalize it and find the value of x or u or v or t or whatever is the variable. Okay. Then we will check its relation, means you find alpha plus beta, you find minus b by a. If alpha plus beta and minus b by a are matching, it is verified. Then we will move to question number 2. Find the quadratic polynomial each with the given as the sum and product, means alpha beta is not given, alpha plus beta given and alpha beta given. So as I said, you can use the long cut one, the describe method. First I have described, otherwise the shortcut. So one problem is there. Suppose the first case, it is 1 by 4 minus 1. So always the alpha plus beta or alpha beta, if it is in the fractional form, suppose 3 by 4. So one good thing you can make. So if something in fractional form, for example in class 9, if something is in the denominator is irrational, you make it rational. Similarly, if in the denominator there is something, you multiply the bigger one in the numerator, means if it is 1 by 4, then you multiply 4 with everything, right side, that is 0. So the right side term will be 0, and the left side you multiply 4 with everything. Whenever there is 4 in denominator, it will be cancelled. Clear? There may be another doubt, sir. one coefficient is 1 by 4, another is 1 by 3. Then what I will multiply? If I am multiplying 4, then 3 is not cancelled. If I am multiplying 3, 4 is not cancelled. In this case, if there are two things in the denominator, you take their LCM and multiply. Suppose the equation is something like that: 3x square minus 1 by 4x plus 1 by 3. So you multiply 12, 4 and 3 both will be cancelled. Okay, so this is the end of 2.2. We have discussed the zeros of polynomial, its relation with coefficient.